All right. Thanks for coming, guys. Hope you had some lunch. So the title is How to Troubleshoot VM Performance Issues Across Applications, Infrastructure, and Storage, Big Data Cloud, using vCenter Operations Management. My name is Praveen. I'm one of the product managers in the vCenter Operations team, and with me is Sam.
I'm Sam McBride. I'm a senior architect for vCenter Operations. I do capacity planning and operations management. So.
Cool. So the format today is that we're just going to start with a quick introduction to the suite. Just before we do that, quick show of hands. How many people are using vCenter Operations in production? Quite a few. Okay. So for the folks new to the product, just a quick introduction, and then we'll jump right into the demo. So we're talking about the vCenter Operations Suite. As you know, VMware wants to provide solutions for the entire scope of the cloud, whether it's from deployment or ongoing operations or trying to find out the IT cost controls, right? So when VMware talks about operations management, we typically refer to these 5 functional domains: performance management, capacity management, configuration, compliance, and cost. And so the reasons why we got into this space is because we looked at the overall landscape, and there were not that many solutions who were looking at some of the virtualization constructs and the dynamicity of the cloud, right? There's a lot of things that you need to do differently in the cloud, especially things like managing at scale. What do I mean by that? You no longer can sort of go after individual hosts and clusters and troubleshoot. You really need to have a holistic perspective. And a lot of techniques that VMware can do there to help you manage at scale. One of the things that we did is that we acquired this company, Integrian, a couple of years ago, and their primary value prop was to use analytics as a means to achieve this management at scale. As in, you manage by exception. You're not going after the point problems of every day. You're looking at trends in the environment and identifying patterns. And you want to do the same thing for all the other domains. It's not just about performance management or capacity management. At the same time, we also understand ops management fundamentally is a cross-cutting discipline. It's not just about vSphere. Typically, when you have an ops issue, it cuts across multiple domains, whether it's the network stack or the storage stack or the app stack. So when we talk about ops management, we fundamentally need that end-to-end view. And to that end, we also have extensions into our software that allows you to bring data from non-vSphere sources as well. So we have a huge management pack ecosystem. Those are some of our partners there. And you can also write your own and bring your own IT data in. And we want to provide that sort of holistic perspective. So we pretty much support anything that is physical, virtual, or even public clouds. And we also have APIs and SDKs in order to sort of extend that visibility as well. So fundamentally, we are heterogeneous. That's the big difference here with VCOps because of the requirements around running operations. So when we acquired this company and Integrian a few years ago, we started bringing that into the overall vSphere suite. One of the things we wanted to do is go after the specific use cases that you guys run into every day. How do you apply management at scale use cases to the problems of today, right? So what we've done is we talked to our GSS team, our PSO team, et cetera, and we've taken a lot of those, the troubleshooting knowledge and the best practices, et cetera, and we sort of codified that into the product. At the same time, we also want to give you the flexibility to view the data the way you want to see it. So for example, here, this is what we call as the vSphere UI. So what you notice here immediately is that it looks very different from vCenter. We start with the problem statement, which is what we call as health, risk, and efficiency. Do you have immediate problems? Do you have future problems? Do you have opportunities to optimize? This is how a vSphere admin typically thinks when he comes into the day. What do I have to care about right now? What are some near-term issues? And what do I need to do when I have some time at the end of the quarter to better utilize my environment? So what you see here are what we call as badges. Think of them as credit scores in a way. Like it's sort of an easy to consume number, which takes into account all of the troubleshooting best practices knowledge and comes up with a single number that describes how healthy you are. And we also have sub-badges, which are individual analytics that sort of roll up into this high-level health score. So when you come in, what you would see is health, risk, and efficiency, and you can sort of drill down by expanding the page to see the sub-badges. Do I have high workload, aka am I pushing more than I should be? Is my environment behaving normally, which is the anomaly score? Do I have any fault events? And the same goes for risk. We have time remaining and capacity remaining, which sort of indicates you near-term capacity shortfalls. And the way we sort of envision you guys using this tool is to sort of cross-cut these different domains. For example, I may have a high workload issue, but let's say my stress levels are low, then maybe I have a near-term issue. But what if my workload is high and my stress is high as well? That means I have a longer-term problem because stress is about taking the workload score and looking at it over a period of time, right? So which means that I need to go fix something. So this is sort of a clean, easy way to look at the environment very quickly and see problems in your overall IT landscape. At the same time, we also want to give you flexibility. So we have this other interface in the product, what we refer to as the custom user interface, where you can bring your own data in and you don't have to go with the out-of-box defaults that we have. And you can bring in data about applications, your infrastructure, et cetera, and you can come up with these different views of the environment which are separated from your vSphere side. So for the first time ever, you can give this tool to your end users, like your app owners or VM owners, and they don't need to have write access to your vCenter environment. You can separate out your operations from your day-to-day run of your vSphere environment, right? A lot of times people say, I don't want to give write credentials to my VM owners. I just want them to see the IT assets that they own and the views of that. So this is a very easy way to do that. At the same time, it's not just about high-level details. We also have ways for you to get really deep into the information that we collect. So what we have here is the next level of drill down, like a details page. And by the way, all of this we're going to go over in the demo, but I just want to sort of set the stage before Sam shows you how you can use all this together. So we have the details page, which allows you to go drill down. You can immediately notice here that all the key metrics are laid out. On the left, you see that there is a quick summary. So very quickly, when you come to a resource, you can figure out who's the worst offender. Is it the CPU? Is it the disk? Is it the memory or the network? You can also correlate information. Classic example is what happened at Sunday morning 9 a.m., right? When you came back into the office, can I go back in time and figure out whether there was a unique performance issue or was it some specific event that caused that problem to happen, sort of cause and effect. And there are multiple ways I can sort of overlay additional information, even from tools such as our VCM product, which is a configuration manager product, which brings in guest performance data or in-guest registry information or software install failures. It's very useful when it comes to identifying whether somebody inside the guest changed something, and you can see that impact right here. And we want to give you the ultimate flexibility in terms of visualizing the metrics. I'm pretty sure you guys are used to performance charts in vCenter. This allows you to sort of slice and dice additional data and look at it side by side. So you can look at CPU information alongside memory information together. And you can see these high watermark and low watermark values. So you pretty much know very quickly, is it behaving normally or is it a peak that I don't know about, right? So enough talk. I will hand it over to Sam for the next portion of the demo.
All right, thanks, Praveen. One of the things that we use our UIs for, especially when diagnosing, either somebody comes to you with a problem, or somebody says go find a problem, or you're just looking around. And so most of the UIs for diagnosing problems are in line with these use cases. So if somebody comes and says, what happened at 9 a.m., I'm not going to go to the live UI, right? And this is kind of a mistake that a lot of people make off the bat, is they try to start with the pretty UI that Praveen showed, which was the custom. Maybe we can switch it. I can just talk to these points. So this is generally when you open the UI, you're looking at this screen. So how many people think this is the most useful screen in the product? No? No one. You like it? What I like about it is that it does give you information at a glance about a particular object or a group of objects. There's no other screen that puts all the ways that we look at an object together like this. But in most cases, we're firefighting, right? And this is not the ideal screen to go to. And if you were to say, if somebody came to you and said, you know, let me find that problem that happened at 9 a.m., this is absolutely not where you're going to go. This is basically the last 5 minutes on the left side, and then in the middle, it's it immediately goes to some planning reports, planning visuals. So the first thing you probably want to look at when you're looking for a problem is really the alerts. All these alerts are listed here, and out of the box, we turn off the active alerts. I mean, I'm sorry, not the active, but the canceled alerts. And so you'll come here and you say, hey, I can't find that alert. And the first thing you want to do is go to this screen, this filter, and highlight that you want to see canceled alerts. Then you can start finding the problem. And so if I was interested in a particular day, I'd put a filter for before, then I would put a filter for after, and I would drill down into what was happening. And so I have the world selected, so I have all these alerts that happen between a certain time, and I picked August, something that I know that happened. And so here, somebody came to me and said, hey, my VM is running slow. So I go and say, okay, where is it? Well, it's on this host, and so forth. So I go and find the things around it. The first thing I want to look for is, okay, is this storage related to this host? And I see the alerts. I see 4 alerts that are related to storage. And particularly, I see disk I/O. So I can drill down into that. And it shows me that something is generating disk I/O on here. And in particular, there's a lot of writes. The line is green. It probably should be red. It's kind of misleading. But the line going all the way over to the right is telling me that the latency is at its max it's seen, and the write IOs are the max that it's seen. So this is the first use case of finding a problem. And actually, it was pretty quick for me to find it because I just knew to go look for alerts first. All right? Does this sound pretty typical of what you guys have? Yeah. And so on this one, since the storage is servicing many VMs, I can see which VMs are using the most space, and I can also go see which ones are using my most I/O. Another visual, and we can move to another problem. So another use case is what is going right now. When somebody is saying something is actively happening, there's a couple use cases or visuals to look at that. One of the things that I like to use is probably the analysis page, which is tree maps. So the tree maps are organized in various ways. We have categories for storage, we have categories for CPU, memory, and disk and network. And so I can look at a bunch of objects, and in particular, I want to look things about virtual machines. I'll get the list whittled down to a set of metrics. And the metrics, there's 2 dimensions to a heat map, or there's actually 3, but the 2 that control the box, the size of the box is 1 dimension, and then the color is the 2nd dimension. And most of our boxes, I would say, the size is generally driven by some kind of work rate, and the color is driven by some kind of latency. And so what that allows it to happen is that I can see quickly who's a villain and who's a victim. If a box is big, it's generating a lot of I/O, and if it's colored, it's generating, it's being impacted. So let's just take one of these as an example. We'll start with CPU. So color by contention, size by demand. We don't have a lot of contention happening right now, but I do have a cluster. I have a VM, which is the Suite VM, an app called Suite, and I have a VM called Log Insight. And Log Insight is got a lot of more latency than the other VMs because it's doing actually its own I/O. And so, in this particular case, imagine that the box is not light green like that, but it's a much more red, or if you will. What would happen is that box, I would see that the Suite VM is generating I/O, the Insight VM is generating I/O, but Insight VM is suffering a lot of latency. And so from there, I can drill down and to see what kind of if it's being impacted by latency, I kind of want to go and see what kind of device that guy is on. And his storage would be highlighted down here. So he is on data store storage 2. And so storage 2 is probably not suited for this VM. He's got not a whole lot of I/O commands, and throughput is not too bad, but the latency is pretty high on the writes. I got 45 millisecond latency. So this I/O, since this guy is doing a lot of reads and he's getting latency on the write, he's probably configured it wrong for this VM. All right.
It's also pretty cool that you can click on the link, what you see there calls "What does this mean?" So if you want to know more about the metrics, we actually provide some guidance on some common troubleshooting use cases based on our experience with support, and we sort of put that into the product. And our goal is to not only put this in textual form, but in the future make them out of box in the product as alerts and other kinds of information. But that's something you can look at if you're not familiar with some of these metrics, and we even give you some tips on how to troubleshoot there.
Right. So now that we're on this screen, this is what we call the detail screen. And there's a lot of information going on here. First, let's just take CPU and break it down. CPU has capacity, which is the width of the box. It's got demand, which is the green bar. And it's got usage, which is the gray bar. And the delta between the demand and the usage is contention. So there's not a whole lot of contention on this particular box, and there's not a whole lot of demand either for CPU. The little stick pin all the way to the right on the CPU is the entitlement, the calculated entitlement for this box. So no matter if you configure the box to have a certain size of CPU, ESX is only going to deliver the CPU that is managed by that entitlement. So if you move down and you look at memory, you can tell my entitlement is much less than the size of the VM. I've sized the VM for 8 gig, yet this box is completely overcommitted, and there's no way that ESX can give that VM 8 gig. It can actually only give it 1.8 gig, which is down below in the entitlement. Back up just a little bit, the little blue line with the two little triangles, that's our calculated expected behavior for this hour. So every hour we calculate dynamic thresholds for this metric and where it should be based on its history. And if it's outside those lines, then you may want to take a look. On memory, it's the entitlement is calculated for demand, not for the usage. So we can, or it's shown for demand, not usage, and it's still operating in that. On the memory, we also have something, kind of this notion of demand versus consumed. And in this particular case, you notice that the green bar is lower than the gray bar. Does anybody know how that happens on memory? So demand goes both ways. It's one of those metrics that if you express it simply as the amount of memory that the VM wants, or the amount of CPU that the VM wants, then that's easy to grok. If you say, okay, it's the amount of usage plus contention, then it doesn't work here. And for CPU, we kind of describe it that way, that it's amount of CPU usage plus contention, because the usage always, invariably, is always less than demand on CPU. But in memory, we can actually give a box more memory than it wants. The amount of memory that it wants is the amount of memory, not that it allocates, but the amount of memory that it actually stores data in. And that's how we express it. And this is the way that we can calculate a write size for a VM, is because we analyze the VM for the amount of memory that it wants. And we use active memory for that one. Is everybody clear on that one? No? So the amount of memory that it got is simply the amount of memory that we provisioned, which is the 8 gig, minus the amount of memory that ESX took back. Because every OS is going to allocate all the memory that it was given, right? So that metric is consumed. Now, let's go take a look at another VM. I have a very leading name for this VM called CoStop. All right. This VM is a VM that I created with a lot of CPUs. And right now it's not doing much. I have a job that wakes up every 6 hours, and we'll see a little line here. And you see this little spark line. So it ran about 2 hours ago. And that when it wakes up, and I'll show you in a minute, the CPU tries to go grab all it says, I want to run my 4 CPUs, and it can't, because it can't find any space on the hypervisor. So for me to look at this and analyze it, my favorite thing to diagnose CPU is to go to the all metrics. If I haven't gotten my information from the alerts and the heat maps and so forth, I generally drive to this UI. And because it's kind of like the oscilloscope. I mean, you just can put all the metrics together and zoom in, zoom out, and so forth. And here we're going to focus on CPU. And immediately I'm just going to grab my favorite metrics. Swap weight. Did I grab the IO weight? Contention. Good stuff. All right. Then I select one of these here, which is zoom all together. And then I zoom into a certain number. I see something interesting here, so I zoom in again. And I start looking around. Okay, so CPU demand. CPU demand or contention is usually caused by something. And on the first graph, you don't know why you have CPU demand. You only know that you have CPU demand, actually, CPU contention. So if somebody's complaining, then that means that the VM didn't get what it wanted, right? And that's called contention. So you want to come here and look at all the metrics that can cause contention. One of the metrics is CoStop. So if I have this VM, every time this VM wants to run, right here on this demand, you see the CoStop go up. And actually it's pretty large. 20,000 is a very high number for CoStop. And that's because it is this case that it's starved. But if I didn't have CoStop, like if I had a single vCPU VM, or I had a host that didn't have this problem of scheduling it, then it's got to be something else. And in this case, if co-stop was flatlined, then I would move to my next metric. And the next metric is I/O wait. So I can actually see sometimes the VM is waiting because of I/O. And so that could be caused by other VMs writing to the box, and it's not being able to, or it itself is writing to the box, and it's not able to, it's waiting on that blocked I/O. For the instructions are waiting for an I/O request to happen, right? And if other VMs are writing on that box, it's possible that it doesn't have a lot, this VM doesn't have a lot of I/O, but it has one I/O that's waiting for those other I/Os to be serviced. If I don't have I/O wait, then I could have swap wait. And it looks like some of my issue is due to swap. So this box has actually probably got a memory problem too, because I have a lot of swap wait in there, and some of the I/O is actually caused by that swapping. And then one of my favorites here that I didn't put on here is idle. And this is the case for the oversized VM. So I've seen many times where a VM will have a high ready rate because it's just being taxed because it's too big. It has a lot of vCPUs, it's not doing anything, and the hypervisor will recognize that and ask that VM to not be scheduled. Well, not ask him, he'll actually tell him, hey, you're not getting scheduled. And so this is one of the ways that I've seen when you go up to the host and you see a lot of usage. Let's go back to details on the host. I probably don't have this case because I don't. I've seen many cases where this demand is really high, but this usage is low. And when it's hard to explain when demand is high and usage is low when both of them are under 50%, right? And that happens when you have one of two things: either a lot of VMs that are running idle, or you can actually get this co-stop problem where you got a lot of VMs on there. They're not using the megahertz, but they're having a hard time scheduling the vCPUs. And so you get this contention. And also remember, these are 5-minute averages. So you can have a significant amount of co-scheduling. Well, not co-scheduling, but we call them conflicting workloads, where you put your database app, your database tier and your web tier on the same box. And what happens? A request comes to the web server, and then it immediately goes to the database, and then it comes back and it gets serviced. So they're all trying to do work at the same time. On average, they're not working hard, but at the time that they want to do work, they conflict. And those are called conflicting workloads. All right.
One of the things we also like to do is look at the relative size of the VM's consumption, right? You can see the bar on the bottom that shows you how the VMs are using the overall demand and usage.
This one?
No, that one.
This one? Yeah, the breakdown, you mean?
Yep.
Yeah. Yeah, this is another useful part of the area, which is if I have a overall for the host, how many megahertz, I can see which VMs are the highest users. In this case, I have a suite VM that is generating a lot of CPU. The others are really low. None of them are probably bigger than, this one might be more than one CPU, but you can tell that I overall don't have a lot of CPU usage. My issue is more about memory on this box. Okay, so the other thing we can do, in some cases you have a situation where you need to either go into a meeting to reclaim capacity or need to find available capacity in your environment to deploy objects. In this area, we often use we don't often, we always use the planning screens. And some of the screens are kind of hidden underneath, excuse me, of they're kind of hidden in this list. So there's a lot of views here that are really helpful. there's views about the capacity, the overall capacity details. In this particular case, I have CPU, memory, disk space, disk I/O, and network summarized. And then I have the columns of total capacity, buffers, usable capacity, capacity remaining, and time remaining. And here we can see that I am over by memory according to my policy, and my policy is probably using allocation. So reservations and demand. So in my particular case, I'm using a lot of reservations, which don't show up in the demand on the operation side, but they do in the planning. And why is that? Because we can't overcommit reservations, right? So if you, on the planning side, we want to look at, we have a different use case, and that's when you're trying to figure out if you can just deploy more VMs or are they the right size. So let's go take a look at some of these reports. Some of the most interesting reports are about reclaiming capacity. One could be this idle VMs. I don't have any. Good. Oversized VMs. This oversized VM list is very helpful to most of our customers. They look at this list, and if we have a situation where I can reclaim a significant amount of CPUs or memory, it'd be worth my time to investigate that.
It's also useful when your developers say they need 8 gigs of RAM with 4 vCPUs. It's sort of go after the conversation and say, look, okay, I'm going to give it to you right now, but later on I'm going to come back with data which tells you how much you're actually using.
Right. Another one is undersized or stressed VMs, which I don't have. And then we have data store inventory, data store waste, virtual machine inventory. All these are available.
And what's also good is that you can also see these metrics over a period of time. So the issue is not right now, but you can see based on my historical trends, how am I tracking? When am I going to run out of capacity for a specific resource like CPU, disk, memory, network? So it's very useful for budget and planning. If your workloads are primarily CPU constrained or memory constrained, you can make some better decisions based on the data that the product tells you.
That's right. So I'll go to this other box. This box doesn't have any VMs. And so one of the views, or some of the views, actually allow you to do this what-if scenario. Now, what-if scenario allows you to change either demand, which is adding VMs, or your capacity, which is adding hosts and or removing hosts. So I can say what happens if I take this host and what was it? It's out of memory. And say add another 64 gig. I'm not going to change its storage. If I change the amount of memory, I see the before and after. It was over by 1 VM, and now it's not. You have 2 VMs. Sorry, my screen. So just by simply saying, okay, what happens if I increase my memory to 64 gig? I have solved my problem right here. I've gone from over to 2 VMs remaining. My trending has changed. Now I have greater than a year remaining, where I had 0 days and so forth.
And one of the cool things about the what-if scenarios is that it's not just about adding capacity, you can also remove capacity. So you can say, for example, I have a budget of 100 VMs that I need to provision next quarter, so I can put those 100 VMs in first. And it's going to tell me, hey, I'm going to run out of capacity maybe next week, for example. Then what I can do is I can say I want to add a couple of ESX hosts in there, and then see what happens. Do I still have enough capacity to meet those 100 VM requirement, or do I need to buy more hardware? So you can model these scenarios where you can even add and remove VMs, for example, and add and remove hosts. And you can combine these scenarios to get a single view of what your capacity requirement is.
Yeah. So I did something slightly different. I did the compare exercise.
Oh, that's actually a very good one too.
Okay, so if I didn't like 2 VMs as an answer, I can actually put another what if and say, what happens if I do, instead of 64 gig, I change it to 128, and it'll tell me the answer. It's all on the fly. So you can do up to 5 of these what ifs for your planning. Okay, at this time, I think I'll do one more, and then we'll kind of open the floor to some questions. I've gone over the metrics. I've gone over some use cases like creating heat maps and looking at the details pages for CPU issues, disk I/O issues, and also, which is the storage that you mentioned, and then also the memory as a big one. What I'd like to do is kind of move over to the custom UI. The custom UI is pretty powerful. Its power is in the flexibility of assembling elements together for how you want to find problems. And some of the favorites that I have are, hopefully it didn't log me out, yeah, is the top 10. You can simply put any metric you want. In a top 10 list and put all those lists together here. Another one that I really like is when people come to me and say, you know, I have this VM that I'm having a problem, either last week or even today. I can go find the VM by name here, CVR-suite. That one looked like it was having a problem. Highlight it. All these visuals are interacting with this one visual that I set up here. And the screen is so small I can't even scroll. But this is the relationship tree. I can tell it's part of that world. It's part of this group, which is gold level. It's supposed to have gold level. And it's part of this vCenter server. These are what we call symptoms. Symptoms can be hard thresholds or dynamic thresholds that are violating. And they're ordered in the list that when we see a hill of problems start to occur, we'll sort those symptoms such that the symptoms that happen first are at the top. And in this particular case, I see something on the virtual machine, which is CPU, start to increase. And you see DT above. Dynamic threshold is where we calculate all the models from the history, and we then compare the current value to its expected value for this hour. And in this case, we have CPU overlap, co-stop, and idle and co-stop again on different instances here, which is instance 1, 0, and 2. And then the data store goes high. Workload indicator is abnormal. And then we have CPU utilization, and then data store, and so forth. And that kind of resonates with what I showed before, which was we looked at the all metrics, and I put CPU usage or demand with co-stop and idle and I/O wait, right? And we saw that co-stop was high, and the demand went high, and we also see that storage was also impacting this VM. So both of those kind of were found in the same way. So I can go see here and say, oh, okay, I see that this VM is having co-stop issues, plus it's having storage issues, and I can address that by going to other VMs.
And what's also cool is that this is actually dynamic. So what you see in these expansions that Sam is doing, it's not a static view, it's actually dynamic. So we're looking at symptoms over a period of time, and you can see what's going on currently. And because this overall dashboard is interactive, it's really great for a level 1 guy or some consumer to have a sort of a sandbox view of the environment, and they don't need to see the inventory and all the other details. They can just quickly look at their resources, see what are the symptoms that they saw at that point of time, and then make a call to the app or app admin or the VM admin for that next level troubleshooting.
I don't know why the screen just refreshed, so.
It's a feature.
Yep, live demo. So I went and selected that co-stop issue that was happening, and then I went to go graph its symptom, and now you can see the graph of the symptom there. This is the DT above. There's the instances that it happened, which is the anomalies detail, and then I can quickly get a graph of the metric over time. And I can close this out and go back to another metric and diagnose it as well.
You can also sort of pull down that metric graph to look at the previous collection cycles. So you can say what happened right now and then go back in time and then have the metrics stacked. So you can sort of have a comparative analysis and say, hey, what happened this week and then what happened last week, what happened last month, and look at that in a stacked form. So you can sort of even do a pattern recognition there as well.
You're talking about the all metrics?
Yes.
Yeah. Yeah, let's finish this one. Here I have the list of symptoms in order, then I have the most interesting metrics. We calculate these dynamically based on the symptoms. Here we're showing you data store issues. And then this nice event graph, which shows you all the things that happened back in time, which is another nice little graph. Excuse me. And we can see that the guest tools started, notification, what is this? It looks like this, a VM was started. This VM started actually. And when it was powered on, seems like this is, this is powering on. And you can see that the anomaly count went high when we rebooted this VM. Another useful area is this, something called cross-silo analysis. This is similar to the details page that I created, the summary, the dashboard that I created for investigating. But in this particular case, it's one that's tailored for finding problems around multiple objects. So if I had a VM such as Suite, hold on. It's going from here back to the US, so it's got a little bit of latency in the UI, but I don't know why it's taking this long. I can select multiple objects and see the anomalies for these objects, if it'll show up, but we'll give it a rest. All right, so while this is coming up, does anybody have, I've pretty much gone through a lot of the product, looked at metrics, looked at alerts, used a lot of the visuals to find problems in various ways, heat maps.
The planning views.
Planning views.
Yeah.
What if? This was one of the ones that I wanted to show you, which I can't seem to get it to respond right now. But is there anything that somebody wants to take away from this this session today? Burning, yes.
I'd like to understand
Surprise.
I'd like to understand a bit more about the badges. So for example, if a data store is 75% full, I regard that to be healthy, but its health value would seem to be 25, because that's the overall amount of storage minus the workload. So
right.
Is it a simple numerical calculation like that? Because it will show up as red when actually there's nothing wrong.
Yeah, so let me address that. Health, it's particularly your question was about data stores. And if you think about filling up a data store, it's not really a workload. It's actually just a consumption. So it's filling up. CPU is a cycle. Disk I/O is a cycle. You know, they're all doing transactions and doing work. So we don't put space on the health side. We put it on the risk side. So you do. You what?
In the foundation version.
In foundation, he said foundation. You get to keep the mic if you want it. So, yes, let's go look at workload. Are you talking about for a data store, particularly? So on every object except for a data store, we have taken space out of the workload area. Wow, it's taking a while. So you're right. In that particular case, it shouldn't be unhealthy unless it was absolutely out of space and it was trying to do a write and got an error, and that would be covered by a fault. For some reason, we chose to leave space on just specifically data stores. We removed it from host VMs from the workload area. We are going to remove it from the workload on data stores as well and only focus on disk I/O in the future. So, and actually, if you want to know, I mean, that was a very targeted question. You kind of asked a little bit about the badges in general, and then you went straight to health. Is that what?
It was a good example of something I didn't clearly understand.
Okay.
So that was why.
All right. So let me maybe just cover the badges in general. Everybody know what the badges are? I didn't cover them in depth because I thought maybe people had already seen it and we were focused on diagnosing areas. But workload, specifically on data store, you see we have disk space and disk I/O. And disk I/O is really what we want to focus on for a data store in the workload area. And we'll eventually remove that disk space. And what this is the last 5 minutes, how high or hard it's working compared to its estimated capacity. And CPU, they give us a capacity. Memory, we're given a capacity. It's either capacity or an entitlement. And then we compare the existing demand against that capacity and we'll throw it red when it gets too high. Anomalies is the second way that we look at instantaneous kind of workloads or metrics. For anomalies, each metric is compared to a dynamic threshold or to a hard threshold, and it generates a symptom. All right. On anomalies, we're really focused on the dynamic thresholds because that is exactly how we're expressing what it should be based on our analytics. At this hour, it should be between, let's say, 2 and 5. And if it's not, it will generate an alarm. Now, we don't care about individual metrics going in alarm. That's not really that significant if a single metric crosses alarm. But if you have 230 metrics, let's say, on a VM, and 20 to 30% of those metrics are violating some expected threshold, then we think that is an interesting event. And so this anomaly score is how interesting is this object as far as DTs, right? You see on this threshold, this visual, you'll see there's a gray line and it says problem threshold 5. What that is a calculated noise line. So all objects have metrics that go in and out of their thresholds expected. And if they do it a lot, that noise line will be high, and if they do it a little, or they have a very predictable behavior, that noise line will be low. And so the score is how close and above is that blue line to the gray line. And here you see the anomaly is 0, and that's because there are no unexpected metrics on this violating thresholds. And then the third one is faults. Faults are very prescriptive. So in vCenter will throw an event and it'll have a criticality to it. And we'll map that criticality to a fault and say HA fails. If HA fails, it'll generate a fault and health immediately goes to red. And health is a function of these three minor badges. Now, risk is the second way area that we look at, and Praveen kind of went over that, but in detail, we look at time remaining, capacity remaining, and stress. These are the things that we consider risk. So you can be instantaneously healthy, but on a path to be to be unhealthy, and that's what we call risk. And each one of these has a way of looking at things. Time remaining is the days that you're going to run out, so we regress the data, the planning data, to the future, and as soon as that crosses the capacity that you have, we'll calculate that time where the intersection happens, and then that gives you your score. Capacity remaining looks at 30 days in the past, or by default. You can change that to be any amount you want. We look at all the spikes and troughs of the workload, and we calculate, how much your effective demand is over the last month, or the demand, your peak demand, if you will, and compare it to your capacity, and then give you an answer. And we, for convenience, translate that answer into virtual machines, because that's what we all use. We're deploying virtual machines, and it's just easier to consume it that way.
A lot of these settings you can also define in a policy. So you can take a bunch of group of VMs, call it production or test, etc., and you can change how the product behaves for those specific groups. And you can move the sliders based on what you want health, risk, and efficiency to be.
Right. And then reclaimable waste or efficiency, it has two badges. One is reclaimable waste and the other is density. We don't calculate density on a data store, so you calculate it somewhere up here on a host. And you'll see that the density score is here. A good example of stress. Seems to be a good host to look at. It has a lot of problems. So my density is 4 to 1. It's actually telling me that I'm way too high. I should be somewhere around 1.6 to 1 based on its calculations, and that's usually due to something. And so it's either CPU or memory. And in this particular case, it's memory. I've just oversubscribed this memory on this box. But that's all the badges in detail. Anybody else have any burning takeaways they want? Yeah. Got a mic? Microphone?
Hi. You covered earlier the ability to create custom dashboards and expose those to end users so people get a real idea of what's going on. Am I able to do that for vCloud Director organizations so that each tenant can see their consumption and at a simple high-level view see their usage? Is that something that's supported at the moment?
Well, I mean, you could do that in a roundabout way. It depends on what you call a tenant.
Yeah.
If you're going to make it public-facing, there's some challenges there on who's the authorizer and so forth. So it's not set up to be like a public-facing website, but you can certainly create dashboards and share it with only a certain group of users that log in. Okay, so we have a security model that somebody could argue provides a multi-tenancy-like environment. On vCloud Director, on that question, we have adapters for it, and we're improving those. And there is especially with vCloud Director, there's that desire to have a self-service portal, and so that blueware is not quite there. Luckily, we're friends with vCloud Director. We know these guys. And so they have the ability to call our APIs and do their own authentication and surface up our metrics in their UI. And that's what they're working on right now.
So I should hassle the VCD people?
Yes.
Okay.
Yeah, you should. Well, you can hassle us too, but we are, everybody wants to go to multi-tenancy. We'll get there eventually, but I think we have 2 paths to go. And if you're ambitious, you can actually write your own UI, little web servlet, and go to our APIs and get that.
Great, thank you.
Just a quick shout out. Just want to mention that we're working on the next release of vCenter Operations. And what we do is something called as an on-site beta. Think of it as a hands-on lab, but except it's a sort of a private environment where we get some of our customers to come in and give us feedback on all the things that we're working on. And the idea here is you can influence the product direction, talk to our engineers and the PM teams, and participate much earlier than the public generally sees the bits. And so we're having that this next month in Sofia, Bulgaria, at our offices there in VMware. And if you guys are interested, we have very limited seats, but you can talk to your sales rep and see if they can put you in for a nomination.
Yeah, so we have 5 minutes. We could take more questions, or if you guys just want to get going to your next place, that's fine. You won't offend us, but I'm glad you attended. Thank you.
All right, thank you.